Alright guys, so this is uh, the third installment of our axis series, which the first video we covered the y-axis, right? Covered the y-axis. And then next to that we covered the x-axis. And so today we're wrapping up with the installation for the z-axis, right? In this particular video, I am not exactly building it as you see, but I'm just showing you design choices, how we made them, why we made those choices like we made them. So in case you have not seen the y-axis, I want you to go back, check the y-axis, and then check the x-axis, because it might be a bit difficult for you to follow along if you just come to the z-axis, but all of them work in tandem. In the first video, before I started talking about the axis, I tried to explain to you that 3D printers sort of print in three axes, right? They print on the y-axis, x-axis, and on the z-axis. It's the combination of those motions that produce objects, like this, right? This object that you see. It depends on which axis you're looking at, but this object exists in three different axes. It exists on the x-axis, it exists on the y-axis, and it also exists on the z-axis. And each of those axes must have their own motion controls, otherwise they are not going to work as intended. So the purpose of this video is to show you how the motion controls were set up before we can then start building. So the z-axis, I can assure you, is one of the easiest to assemble. There are basically two components of the z-axis. You already are familiar with the motor, so those are not the components I'm talking about. But the thing that really does the motion control for the z-axis are these two linear screws, right? These things are called linear screws. But see, these linear screws don't work by themselves. They work in tandem with this. If you've watched any of these 3D printer builds, you notice that they have this particular plug right on top of your linear screw. And the job of that plug is, what it does is it clips to whatever you have chosen to attach to the x-axis. Once it is attached and then the linear screw is placed inside, the screw can easily do its motion up or down depending on which direction you follow, right? And so because this particular screw always works with this, it's the reason why you always have to buy them together. So let's say, for instance, you're shipping them in. When I first shipped mine, though it came with it, took me a while before I could notice. So I had to bring this in separately. Without this little golden thing, you cannot assemble the z-axis properly. And the only reason is that you have to connect the z-axis to the x-axis. While I was trying to explain the x-axis to you last week, I tried to show you that you always have to connect the x-axis to the z-axis in this particular type of 3D printer build. The reason being that it's the z-axis that actually lifts the x-axis. So the z-axis is always connected to the x-axis. It might not be immediately apparent when you watch those videos, but that's basically why they do that. In some cases, it can just be brackets that are here. It could be 3D printed. It could be, in this case, I just used an acrylic. I just cut a acrylic in a very untidy manner and then placed them in. And then it works just fine. Once in a while, this one does pop out, and when it does, you just screw back on and then it just starts to work. So what you want to do is get a small clip, usually a 2x2 inch clip is just fine. All you need is for it to plug into your x-axis this way and then plug into your x-axis that way. And then the same thing goes on here. So it's just basically two screws I have on here, and then two screws I have on here that is attached to the z-axis. And you can see that by the time I start twisting the z-axis in one direction, the carriage begins to go up. If I twist it in the other direction, the carriage begins to go down. So the z-axis is useless if it's not attached to the it's the x-axis. So that's why when I was explaining x-axis, I had to add z-axis to it. The same goes for the z-axis. So it's very easy. We already had these two beams assembled, right? And so z-axis is just always mounted to this. And the job of the z-axis is to lift the x-axis up and down. Why? Because the z-axis, right, is the one that really controls how high this thing is from the plate. Right? So the z-axis is not by itself. The only guy that is by itself in this particular equation is the y-axis. In this particular type of build, the z and the x-axis are married together. And so the z does the job of lifting this up and down, lifting this up and down, right? So you have to keep that in mind, that in this particular type of build, the x-axis needs to go up and down. And the guy that does that job is the z-axis. Now, there are some other kinds of 3D printers where the plate lifts up and down. In that case, it would be the plate that is attached to the z-axis. But that's not the kind of build we have in this place. In this particular type of build, the z is married to the x-axis. Do you have to do it this way? Well, Ender 3s are like this, right? So it depends on the kind of builds that you want. I think this is quite common on the internet. You see a lot of things like this on YouTube if you want to build it. So you have to keep that in mind. That's pretty much it. You need two motors for the z-axis. And then those two motors are fastened to this particular x-axis. Now, remember one time I was telling you about the sag? Well, if you only had one motor on this side, let's say for instance on this side, then by the time you're lifting this guy up, can you see that only one side is going up while this place is stationary? So in that case, you would have a sag, right? It sags down this way. If you print this way, it's not like it's not going to print. It's just that this guy would be tilting up like this. So this base will just be going up like this. It's not going to print right. So balance matters, right? So when you're setting the z-axis, always make sure that the x-axis is flat. Can you see that both of them are moving together? So it's not like it's a big deal. It's just that you have to hold this guy down while you adjust this guy to stay center and balance. So by the time I turn on the system now, the next video, I'm going to turn on the system. Then I'm going to show you all the axis control connected to this particular machine. And then you see how everything works together. I think, no, before that, we're going to have to then talk about setup and the wirings for everything to the ramps 1.4 and then the Arduino. All right. So that's pretty much it. I'm going to have to do a quick recap. When you're building 3D printers, you need 4 different components. You need the frame, right? And the frame, like we said, is the rigid structure that you have for your 3D printer build. So for this place, we mostly always use a 2x2 mm aluminum frame, right? Let me show you what a 2 mm aluminum frame looks like. So you see 40 by 40 mm extrusion, right? So sorry, in the past I said 2 mm by 2 mm. So that's 40 by 40 millimeters. So we always try to use this because it's rigid. If you can't get this in your country, then you're going to have to import it, right? But that's pretty much it. The reason we use it is because it's sturdy and then it can take the weight of the print. Then for the frames, this tall standing frames, we use a 20 by 40. So it's 20 this way and then 40 across. Some people could just choose to use a 40 by 40 for everything. It doesn't really matter. What matters is that you have a setup that works for you. So there's no particular person marking your script and saying this is how best you should use it. If you have your own 3D printer, you can figure out which one they use. Once it is slim and wide like this, it's a 20 by 40. And once it's bulky and thick like this, it's a 40 by 40. So it doesn't really matter what particular aluminum frame you pick or use. All of it works right. The most important thing is that you need a sturdy frame. That's number 1. Number 2 is that you need to then figure out the motion controls along that axis. You can see that as I'm moving this thing, the brace frame is not moving, right? So that's why you need something rigid. Because just imagine if this were paperweight and then we're moving this, the whole printer would just capsize. So you need something rigid that can stay, right? And then you can then do your motion, right? Because these things are going to be moving thousands of times before you complete any particular model. So you need something that is very rigid and very strong. And so after that, you then need to figure out the x-axis, right? And we said the x-axis is always perpetually married to the z-axis in this particular kind of build. So the z-axis, other than the fact that the z-axis enters into this particular knot, and then that knot is attached to this place, there's nothing else that we need for the x-axis, right? It doesn't require any special bearing and all of that. All it requires is just this guy. So this guy is the bearing that controls the leaf spring. Or could you use something else? Of course, yes, you could have used a linear rod, or you could even use, for the z-axis, you could also even use a linear rail, like I said in the x-axis. So whatever choice you make, I don't want to label that, is up to you. The most important thing is that you need something sturdy, you need something rigid that can take the weight of it. And once you have that, I think we're pretty much done, right? And then the next part of this video would be, how do we mount everything here to RAMS 1.4 and Arduino? And that's what you're going to see in the next video. All right, guys, bye-bye. Take care. I hope this helped you. If it has, I want you to hit the subscribe button, turn on the like button, and I'll see you in the next video. Bye-bye. Take care.